329 reads, the shell of the land snail Licom something has two possible color forms, streaked and pallid. In a certain population of these snails, 60% of the individuals have streaked shells. Suppose that a random sample of 10 snails is to be chosen from this population. Find the probability that the percentage of streaked shell snails in the sample will be, and it lists off several things. So in this case, we are taking a sample of 10 shells. Each shell has the probability of 60, or 0.60, of being streaked. Okay, and we want to know, in part A, what is the probability that 50% of our sample is going to be streaked. So 50% sample has streaked shells. Okay, so in other words, out of a sample of size 10, we're curious what the probability is that y equals 5. That's going to be 50% of our sample of 10 shells. Okay? The binomial distribution, in this case, can be used. All right? It is possible for us to create a tree, all right, that's 10 layers deep, okay, and then count how many times how many samples there are where 5 shells are streaked. But of course this is going to be extremely tedious and time consuming. So the binomial distribution says if we have a sample of size n and we're choosing k to be streaked, we take the probability of being streaked times how many we're interested in times the probability of not being streaked and the remaining shells. So in this case, we have 10 shells and we're interested in if 5 are streaked. And so we plug in 10, 5. P is equal to 0.6. 5 of the shells have to be streaked with that probability. And the remaining 5 shells will have to be not streaked. Okay? Or pallid, I guess. And of course, we have to find out how many different ways there are. So 10 choose 5, I believe is 252. 252 times 0.6 to the 5, which is equal to 0.07776 times 0.4 to the 5, 0.01024. Okay. That equals 0.2007. So about 20% probability that out of our 10 shells, exactly 5 will be streaked. B is very similar, except now it's asking the probability that 60% of the sample has streaked shells. So in this case, that means we're going to have 6 streaked shells. So in this case, we have 10 choose 6. We need streaked shells, 6 of them, and the non-streaked shells, or pallid ones, 4 of them. 10 choose 6 is 210. 0.6 to the 6 is 0.046656, and 0.4 to the 4 is 0.0256, and this totals out to be 0.2508. So about a 1/4 or about a 25% chance that out of our 10 shells, 6 of them will be streaked. And lastly, it asks for 70% of the shells to be streaked out of our 10 shell sample. Okay, so that's going to be 10 choose 7.6 raised to the 7. So 7 of them will be streaked, and the remaining 3 will be pallid. Probability of being pallid is 0.4, and this is just a matter of punching things into your calculator now. 120 times 0.6 to the 7. And here we get about a 20.2150% chance. So our answers are, this is for 5 shells, exactly 5 shells, exactly 6 shells will be streaked, and exactly 7 shells will be streaked.